We will now discuss few laws of vector addition. Let us start with the commutative law of vector addition. Consider two vectors, a bar and b bar. The vector c bar is defined as the resultant vector obtained by adding the vector a bar to the vector b bar. If we change the order of addition and add the vector b bar to vector a bar, we get the same resultant vector c bar. Thus the order of addition does not matter. Adding vector a bar to vector b bar gives the same result as adding the vector b bar to vector a bar. Therefore we can write a bar plus b bar is equal to b bar plus a bar. This is the commutative law of vector addition. We will now discuss about the associative law of vector addition. When there are more than two vectors, we can group them in any order as we add them. Thus, if we want to add vectors a bar, b bar, and c bar, we can add a bar and b bar first, and then add their vector sum to c bar. Therefore, adding the vectors a bar and b bar first gives the resultant vector a bar plus b bar. Adding this vector to the vector c bar gives the final resultant vector. If we repeat the same steps but this time add the vectors b bar and c bar first, and then add the resultant to a bar, we get Comparing the two results, we can conclude that the result obtained in both the cases is the same. Therefore we can write a bar plus b bar plus c bar equals a bar plus b bar plus c bar. This is the associative law of vector addition. We will now discuss the concept of a negative vector. Given a vector b bar, the vector minus b bar is a vector with the same magnitude as b bar, but the opposite direction. Adding the two vectors would yield b bar plus minus b bar, which is equal to 0. Note, however, that no vector is ever negative in the sense of its magnitude. The magnitude of every vector is positive. A minus sign tells about its direction. We will now discuss the concept of vector subtraction. We can define the vector subtraction as the addition of a negative vector. Thus adding minus b bar has the effect of subtracting b bar. Therefore d bar is equal to a bar minus b bar implies d bar is equal to a bar plus minus b bar. That is, we find the difference vector d bar by adding the vector minus b bar to the vector a bar. To subtract the vector b bar from the vector A bar. First, reverse the direction of the vector B bar. Second, add the obtained vector minus B bar to the vector A bar using the tail-to-tip method or parallelogram method of addition. Note that, although we have used displacement vectors in the examples, the rules for addition and subtraction hold for vectors of all kinds, whether they represent velocities, accelerations, or any other vector quantity. The only restriction is that we can add or subtract only vectors of the same kind. For example, we can add 2 displacement vectors or 2 velocity vectors. But adding a displacement vector and a velocity vector is incorrect. In arithmetic of scalars, that would be like trying to add 34 seconds and 16 meters.